What's up everyone, it's Stack Lessons here. Welcome back to the channel. Today we're diving into secondary services, QuickSight, OpenSearch, AppFlow, and Data Exchange. Let's get into it. By the end of this video, you'll be able to map 9 secondary Amazon Web Services to the exact scenario phrase that points at each one. Your Salesforce data sits in a silo. Your logs become unqueryable after 30 days. Your partners still upload files over SFTP to a server you maintain. Amazon Web Services has a managed service for each of these panes, and the skill we're building today is instant recognition. Hear the keyword, name the service. We'll move fast, one service at a time. These 9 services are the ones architects reach for when a standard service hits its limits. When an S3 upload needs an SFTP facade for external partners, that's Transfer Family. When Elasticsearch needs a cheap warm tier for older logs, that's OpenSearch UltraWarm. When Salesforce data needs to land in Redshift without a single line of code, that's AppFlow. Each one exists because Amazon Web Services recognized a recurring pain point and turned it into a managed product. Each service we cover has a signature phrase that locks in the answer. A scenario that names a software-as-a-service application points to AppFlow, graph traversal points to Neptune, managed SFTP points to Transfer Family. For each service, we'll cover the same 3 things: what it does when it's the right pick and the one thing it is not. Let's start with QuickSight. First up, Amazon QuickSight, a Amazon Web Services fully managed business intelligence service. No servers to provision, no per-seat licenses to negotiate. Built right in are machine learning features. Anomaly detection on your metrics, time series forecasting, and auto-narratives that write a plain language summary of what the chart shows. QuickSight is also embeddable, so software-as-a-service vendors can drop multi-tenant dashboards into their own apps without rebuilding them. When the scenario says business dashboards, visualize, or embedded analytics, this is your default answer. The engine that makes QuickSight fast is called SPICE, the super-fast parallel in-memory calculation engine. Amazon Web Services describes it as a combination of columnar storage, in-memory technology, and machine code generation for rapid interactive queries on large datasets. The important part, SPICE is a real engineered engine, not just a cache. It preloads your data into memory so dashboards respond in subseconds without hitting the source database every time. Think of SPICE as meal prep for dashboards. Instead of cooking from scratch every time someone opens a report, which would hammer your source database, you pre-cook the data once and put it in the fridge. Every analyst grabs a plate in seconds. That's why SPICE is both fast for users and gentle on the warehouse it pulls from. Here's where QuickSight fits and where it doesn't. It's perfect for business dashboards refreshed hourly or daily, embedded analytics, no-code anomaly detection on key metrics, and offloading reads from your warehouse. But because SPICE caches refresh on a schedule, QuickSight is the wrong pick for real-time streaming dashboards. For that, reach for OpenSearch or managed Grafana. It's also not the answer for heavy custom machine learning pipelines, where SageMaker wins, or for raw log search and tailing. Service number 2, Amazon OpenSearch Service. It's Amazon Web Services' managed fork of Elasticsearch, and it ships with OpenSearch dashboards, formerly known as Kibana, for visualization. It's the default answer for search, log analytics, or near real-time observability scenarios. The feature that earns OpenSearch its exam questions is tiered storage, hot, ultra-warm, and cold, and it pairs naturally with Amazon Data Firehose, which streams logs straight into your indexes with no glue code in between. Picture your closet. The hot tier is the clothes hanging in front, this week's logs on local SSD, fastest and most expensive, fully readable and writable. UltraWarm is the bin under the bed, older logs backed by S3, much cheaper read-only, but still directly queryable. And cold is the box in the garage, archival logs at around 2.5 cents per gigabyte per month, sitting in S3 with no compute attached. As you move from left to right, cost drops and access friction climbs. Here's the official definition, and it's worth memorizing the shape of it. UltraWarm nodes are a fully managed, low-cost, read-only warm storage tier for older and less frequently accessed data. The queues to lock onto are read-only and older. When a scenario asks for cost-effective storage of older logs while keeping them queryable, UltraWarm is the answer. And here's the queue that separates UltraWarm from cold. Cold storage is not directly queryable. To run a query against cold data, you first reattach those indexes to UltraWarm. So if a scenario describes ad hoc analytics on older data without any reattach step, the answer is UltraWarm, not cold. Cold is for compliance archives and forensic investigations, where you accept that extra step before reading. Next up, Amazon Web Services AppFlow. Think of AppFlow as a USB cable with pre-built adapters for every major software-as-a-service app. It ships with managed connectors for Salesforce, Slack, SAP, ServiceNow, Marketo, and Zendesk. It lands the data in S3 or Redshift, either as a full load or on a recurring incremental schedule. There's zero custom code involved. You configure the flow in the console, set the schedule, and you're done. It replaces the Lambda function, the Amazon Web Services Python SDK, and the OAuth plumbing you'd otherwise have to build and maintain yourself. The official positioning is crystal clear. AppFlow is a fully managed integration service for exchanging data between software-as-a-service applications like Salesforce and Amazon Web Services services like S3 and Redshift. Notice the two anchors in that sentence: a named SaaS source on one side and an Amazon Web Services target on the other. That's the shape every AppFlow scenario takes. The queue is a named software-as-a-service application plus no custom code. When you see both together, AppFlow wins over Glue and Lambda every time. A common pattern is pulling Salesforce objects into S3 as Parquet files, with daily incrementals and zero Glue code in between. Now the nuance? AppFlow cannot use a JDBC connection to reach a Redshift cluster sitting in a private subnet. Direct private connectivity is possible through the Redshift Data API, but the standard production pattern is simpler and more common. Land the SaaS data in S3 first, then copy it into Redshift from there. AppFlow is also not a general-purpose extract, transform, load engine. Its transformation logic is intentionally limited. For heavy reshaping or joins, land the raw data in S3 and let Glue or Redshift do the real work. Service 4, Amazon Web Services Data Exchange. Picture an app store but for data sets. You browse, you subscribe, and the data shows up in your account. No FTP credentials, no emails to vendors, no manual downloads. The catalog spans more than 35 products from over 300 providers, including Reuters, Foursquare, and Dun & Bradstreet. Delivery happens 3 ways. Files dropped into your S3 bucket, Redshift data shares, or API endpoints. And it's all billed on your normal Amazon Web Services invoice. When the scenario talks about enriching a pipeline with third-party data, weather, demographics, financial feeds, this is the answer. One thing to keep straight: data exchange is a distribution layer, not a data lake and not a warehouse. It delivers the bytes to you, and then you still need S3 to hold them, Redshift to load them, or Athena to query them. A restaurant analytics team might use data exchange to pull Foursquare location data into their stack, but they still own the storage and the analytics on top. Those 4 services were the ones in the title, but 5 more secondary services show up on the same exams, so let's run through them at the same pace. First up is EventBridge Pipes. Think of it as a serverless conveyor belt with 4 stages. The source is one event producer, SQS, Kinesis, DynamoDB Streams, Kafka, or MQ. The optional filter stage drops events you don't care about before they cost you any compute. The optional enrich stage runs a Lambda or step functions call to add context. And the target is one destination, Lambda, SNS, SQS, step functions, or a PI gateway. The keyword is point-to-point, one source going to one target with 2 optional inspection stations in between. Amazon Web Services puts it in one sentence. Pipes are intended for point-to-point integrations between supported sources and targets, with support for advanced transformations and enrichment. Those 4 words, point-to-point, are the keyword that distinguishes pipes from EventBus rules. Memorize that contrast. Here's the side-by-side. EventBridge Pipes is one source going to one target with built-in filter and enrichment stages, drawing from SQS, Kinesis, DynamoDB Streams, Kafka, and MQ. The keyword Q is point-to-point with filter. EventBridge rules, the EventBus side of the service, is many-to-many, doing pattern matching on an event bus with up to 5 targets per rule. Its keyword queues are fan-out and multiple consumers. When you see one of those phrases, you know which one to pick. Amazon Web Services Transfer Family is like hiring a mailroom clerk instead of building your own loading dock. Partners drop files using SFTP, FTPS, or plain FTP, and the clerk silently files them into your S3 bucket or EFS file system. The 2 identity provider modes you need to know are service managed, where Amazon Web Services stores the user credentials directly, and the Lambda-backed custom mode, where a function authenticates users against Cognito, Microsoft Entra Identity, or any corporate directory. There are 2 more modes for Amazon Web Services Managed Active Directory and a PI gateway, but the 2 above are the ones tested most often. When the scenario says partners upload via SFTP without managing servers, this is the answer. One catch worth knowing, Transfer Family is fully managed, but it is not free. You pay per protocol hour the endpoint is running, plus data transfer. So if the scenario describes internal users uploading to S3, the right answer is the S3 API or the CLI, not Transfer Family. Reach for Transfer Family when external partners genuinely need an SFTP endpoint. Amazon Web Services Batch is the answer for large-scale parallel jobs. You define job queues with priorities and compute environments, and Batch handles the rest, provisioning EC2 or Fargate capacity when jobs arrive, and tearing it down when the queue empties. It supports EC2 spot instances for up to 90% savings on interruptible workloads. The classic Batch use cases are genomics pipelines, Monte Carlo financial risk models, rendering farms, and overnight extract transform load backfills. Look at the cost comparison. On-demand pricing sets the baseline at 100%. Reserved instances bring you down to roughly 60% if you commit. But Spot can land at 10% of on-demand. That's the up to 90% savings Amazon Web Services advertises. The catch, Spot capacity can be reclaimed with a 2-minute warning. So your batch jobs need to be idempotent and restartable. That's why Monte Carlo simulations dominate batch case studies. Each iteration is independent and safe to retry. Use Batch for thousands of parallel containerized jobs, idempotent and restartable workloads, cost-sensitive runs that can tolerate spot interruption and overnight backfills. Do not use Batch for stream processing. That's Kinesis data streams or managed service for Apache Flink. Do not use it for sub-second request and response. That's Lambda. Do not use it for long-running services, that's ECS or EKS, and never run non-idempotent jobs on Spot, because the 2-minute reclaim window will eventually corrupt your output. Amazon Neptune is Amazon Web Services managed graph database. A relational database is a stack of spreadsheets connected by foreign keys. Finding friends of friends who like pizza means joining 8 tables. Neptune is a giant cork board with strings between pinned photos. Just follow the string. Nodes, edges, and properties are first-class citizens. Neptune supports 3 query languages, Gremlin, OpenCipher, and SPARQL, and it's purpose-built for fraud detection, recommendation engines, knowledge graphs, and graph-augmented retrieval. Multi-hop traversals that would take complex SQL joins return in milliseconds. Amazon Web Services' own positioning ties it together. Neptune is a purpose-built, high-performance graph database engine optimized for storing billions of relationships and querying the graph with milliseconds latency. The phrase to anchor on is purpose-built. Neptune is not a key-value store and not a general database. Pick it when relationships are the data, not just a side effect of having ID columns. Here's the decision rule. If you see any of the 3 graph query languages, Gremlin, OpenCipher, or SPARQL, pick Neptune. If the scenario describes highly connected data, multi-hop traversals, fraud rings, or social recommendations, pick Neptune. Otherwise, don't. Many teams reach for Neptune just because their data has ID fields, then realize Aurora with well-indexed joins would have served them better. Traversal must be the primary access pattern. Finally, Amazon Keyspaces, Amazon Web Services Serverless, managed Apache Cassandra-compatible service. Think of Cassandra as a fleet of identical filing cabinets, each holding a wide row of related data. That model is perfect for time series because today's sensor readings all stored in one drawer, sorted by timestamp. Keyspaces uses CQL, the Cassandra query language, so existing Cassandra apps and drivers drop in without rewrites. It delivers single-digit millisecond latency at high write throughput. The sweet spot is Internet of Things time series, fleet tracking, and trade monitoring. And here's the cue that separates Keyspaces from DynamoDB. If the scenario mentions Cassandra, CQL, or wide column, the answer is Keyspaces. DynamoDB is the distractor on those questions. Both are non-relational, both are managed, both scale, but the keyword tells you which managed service Amazon Web Services wants you to pick. Here is the rapid-fire decoder, all 9 services in one slide. Salesforce, Slack, or SAP with no custom code goes to AppFlow. Third-party data marketplace means Amazon Web Services data exchange. Managed SFTP landing files in S3 is Transfer Family. Graph, fraud, or recommendations is Neptune. Cassandra, wide column, or CQL is Keyspaces. Point-to-point with filter and enrich is EventBridge Pipes. Cheap older logs that are still queryable is OpenSearch UltraWarm. Large parallel jobs with spot savings is Amazon Web Services Batch. And embedded business intelligence dashboards is QuickSight. Here's the frame that makes all 9 of these stick. Every one of these services exists because Amazon Web Services recognized a pattern, a recurring integration pain point, and turned it into a managed product. SaaS data trapped in a silo became AppFlow. Partners needing SFTP became Transfer Family. Older logs costing too much to keep hot became UltraWarm. When you see that pain described in a scenario, the service name is the answer. You've now mapped all 9 pains to their services. Let's prove it with a quick 5-question quiz. Question 1. A retail company wants to pull customer records and opportunities from Salesforce into S3 every hour, then load them into Redshift for analytics. The team wants zero custom integration code. Which service should they choose? Is it A, AWS Glue with a custom JDBC connector to Salesforce? B, AWS AppFlow into S3, then copy into Redshift? C, AWS Lambda using the Salesforce REST API? Or D, AWS Data Exchange subscribing to the Salesforce dataset? Take a moment to think about it. The answer is B. AppFlow has a managed Salesforce connector and lands data in S3 with no code. Because AppFlow cannot reach Redshift inside a private subnet directly, the production pattern is AppFlow into S3, then copy into Redshift. Data Exchange is for third-party marketplace data, not your own Salesforce tenant. Question 2. A security team retains application logs for 18 months in OpenSearch. The most recent 2 days must be searchable in sub-second time. Logs older than 2 days are queried only occasionally for incident investigations. They want the lowest cost while keeping older logs directly queryable. Which configuration fits? Is it A, keep all 18 months in hot nodes for consistent performance? B, hot for 2 days, then move older indexes to UltraWarm? C, hot for 2 days, then move older indexes straight to cold storage? Or D, export older logs to S3 Glacier and re-import on demand? Take a moment to think about it. The answer is B. UltraWarm is the S3-backed, read-only warm tier built exactly for older, less frequently accessed logs that still need to be directly queryable. Cold storage is cheaper, but it's not directly queryable. You'd have to reattach indexes to UltraWarm before running any query, which fails the requirement in the scenario. Question 3. A fintech company needs to detect fraud rings, groups of accounts that share emails, credit cards, or IP addresses across multiple hops of relationships. Queries must traverse 5 or more relationship hops in milliseconds. Which database fits? Is it A, Amazon DynamoDB with a global secondary index per relationship type? B, Amazon Aurora PostgreSQL with recursive CTE queries? C, Amazon Neptune using open cipher traversals? Or D, Amazon Keyspaces with wide column partitioning by account ID? Take a moment to think about it. The answer is C. Multi-hop relationship traversal is the textbook Neptune use case, and the mention of open cipher is a dead giveaway. Recursive CTEs in Aurora work but get slow at 5+ hops on billions of rows. DynamoDB and Keyspaces are not built for graph traversal. They're key value and wide column stores. Question 4. A genomics startup runs 5,000 independent variant calling jobs nightly. Each job runs in a container for 30 to 90 minutes and writes results to S3. The team wants to minimize cost and accepts occasional job restarts. Which service combination fits best? Is it A, AWS Lambda triggered by S3 events with reserved concurrency? B, Amazon ECS with Fargate running on on-demand pricing? C, AWS Batch with a compute environment using EC2 spot instances? Or D, Amazon EMR with a long-running cluster and step functions? Take a moment to think about it. The answer is C, AWS Batch is purpose-built for thousands of parallel containerized jobs, and Spot delivers up to 90% savings over on-demand. Because the jobs are independent and tolerate restarts, Spot Reclaim is acceptable. Lambda's 15-minute timeout rules it out for jobs running 30 to 90 minutes. Question 5. A team needs to ingest events from an Amazon SQ drop events that don't match a specific pattern, enrich the remaining events with a Lambda call, and deliver them to a single-step functions workflow. Which service is the best fit? Is it A, EventBridge rules route the queue events through a rule with multiple targets? B, EventBridge Pipes point-to-point from one source to one target with built-in filter and enrich stages? C, AWS AppFlow configure a flow from SQS to step functions with no custom code? Or D, AWS Transfer Family, use an SFTP endpoint to forward events to the workflow. Take a moment to think about it. The answer is B, EventBridge Pipes is purpose-built for one source-to-one target integration with optional filter and enrich stages in between. EventBridge Rules is for many-to-many event bus routing. AppFlow moves data between SaaS applications and AWS services. Not from SQS, and Transfer Family is for managed file transfer over SFTP, FTPS, or FTP. The Q here is the four-stage shape: one source, filter, enrich, one target. That's pipes. And that's a wrap on secondary services: QuickSight, OpenSearch, AppFlow, and Data Exchange. If this helped you out, smash that like button and subscribe for more. See you in the next one.